Now we are moving to the third speaker, 1063. Available?
Yes.
Okay. 1063, crop and fertilizer recommendation system for Android using machine learning, is going to present by Dr. Pintu Chandrashil. And before I invite him, I have found his biography here. Dr. Pintu Chandrashil received the BSc degree in Computer Science and Engineering from Khulna University of Engineering and Technology, Bangladesh in 2003, MSc degree in Computer Engineering from Politecnico di Milano, Italy in 2008, and a PhD degree in Intelligent Information System from University of Fukui, Japan in 2013. He is currently working as a professor in the Department of Computer Science and Engineering, Khulna University of Engineering and Technology, Bangladesh, where he is a member of the Computational Intelligence Research Group. He has authored and co-authored more than 60 papers in international journals and conferences. His current research interests include fuzzy systems, evolutionary computation, neural computing, machine learning, and bioinformatics. Now it is your time. Dr. Pintu Chandrashil, please limit your presentation by 15 minutes. Thank you.
Thank you, Session Chair. Firstly, I would like to thank the organizing committee to give me the opportunity. Good afternoon, Session Chair, co-session chair, audience, organizer. I would like to present crop and fertilizer recommendation system for Android using machine learning. And this research work is actually one of my master's student. He is now doing this type of research. This is the presentation outline. At first, problem statement, why this type of approach, and some related works and objective, our goal of this research, then some theoretical background, and what is our approach, and finally we show some experimental results, conclusions, and discussion. Actually, soil is an essential component in the agriculture field for crop production, and soil type identification and selection are the first steps in crop growing process. In Bangladesh, we know that Soil Resource Development Institute has recognized over 500 soil series. And how we define the soil series? If we soil series is the set of series that have same parent materials, drainage, vegetation, and climate condition. And in this case, we used a machine learning technique for soil identification. Then we recommend some crops based on this soil. And then we built a Android-based application for crop recommendation system. So why this type of approach? Why this type of method? This is actually our improve our economy, improve our nation development. In order to maximize the crop production for ensuring the rising demand for food due to rapid population growth with limited land resources, machine learning based soil classification method are necessary, and I think that this is very time demanding. Due to this reason, a model for soil identification using machine learning based approach, in this case, we used multi-gene genetic programming approach for crop recommendation system. And I think that these apps will help to enhance the crop production, since for crop production has need proper identification of soil. And This is our some related works, and I think that this is the first research work in our country. And there are a lot of related works, lot of sustainable number of works actually based on Pakistan, India, and Nigeria like this. And these are some examples. And they used some machine learning method like a support vector machine, neural network, naive-Bayes fuzzy logic, and clustering type methods. This is the actual objective of our method. At first, we propose an automated method for identifying various type of soil series data, and then we recommend some crop production and fertilizer recommendation. Then we built a Android-based application for soil classification and crop recommendation system. In this case, we collect some data at Khulna region of Bangladesh, and for this, we support Soil Research Development Institute, and this is the government farm for soil research center. And actually, we built a computational model. Then we validate this model by applying it our collected data set and analyzing the experiment outcome of our proposed methods. And I just overcome this. And this is some theoretical background of multi-gene genetic programming approach. And this is the evolutionary approach. We start by generating some randomly generate initial population, then evaluate the initial population by using some objective function. Then we check the termination condition. If satisfied the termination condition or maximum number of generation, then we get the best individual, and this is the probable solution of our computational model. If we not reach the termination condition, then we get generate the new population by applying elitism, crossover, and mutation technique. And this is the flow chart of genetic programming paradigm. And this is the overall functional block diagram of our proposed technique. At first, we collect some soil dataset, then we apply pre-processing technique to remove the erroneous, irrelevant features from the dataset. Then we apply the multi-gene genetic programming approach to build our computational model. Then we get the output from the computational model, like as the soil sample, classify the soil samples. Then we apply the crop dataset, our collected dataset, and we recommend actual crops based on the soil classifications. And this is, at first we collect the dataset. We collect the dataset from Khulna regions, different upazilas, and in this we support from Soil Research Development Institute. And then we apply data pre-processing technique. In this case, we remove some erroneous dataset, and we select the best features, soil features, to build the computational model. And this is some features of soil, like as pH, salinity, organic matter, calcium, magnesium, potassium, sulfur, boron, copper, iron, and zinc, like this. And this is their measuring unit. And this is the overall functional block diagram. Here x1, x2, and x3 are the features of the soil series. Then we apply some functional products to build the mathematical model. Then we apply fitness function to evaluate each gene. Then we get the best gene, and this is the potential solution of the computational model. And this is the some example of gene 1 and gene 2 and their respective mathematical model. And this is another gene 5, 6, 7. And our target is to build a efficient model. For this reason, we apply the six-fold cross validation technique, which randomly partition the input data set in 6 dataset, and one is used for training purpose and another node is model validation purpose. And in this case, we used the fitness function, and the fitness function name is mean square error, RMSE, and we calculate this mean square error by using this equation. And this is the overall mathematical model of our proposed method. And this is the functional function of the proposed method. Here y equal to y is the output, and f is the function of features of the soil series. And this is the overall function of our proposed model. And this is the fitness function, root mean square error, and RMS error. Finally, if the soil sample is accurately classified to their respective classes, we recommend the crops based on the samples using input from dataset. But if the soil is not accurately classified, then no recommendation of crop is done for the soil samples. For crop recommendation, at first, proper classification is very important. And if the soil sample is misclassified, then crop recommendation for the sample is not use. And here some examples of some উপজেলা of Khulna district, like as Rupsha, Dakob, Digulia, Terokhada, Phultara, Koira, and upazelas. And we collect 10 samples of dataset, and we built the model. And this is some soil classes, like as Gyur mid low level and Hatro mid low level, like this, and we label this 1 to 11. And this is the some example of crop data set, like we class level like this 10, 1, 4, 7, and 9. And this is the some crops, potato, wheat, legumi, sesame, and foxtail, millet, and rice. And at first, we have to build the computation model. So to build the computation model, we know that we have to set some parameters, like as population size, used number of generation, category of crossover, number of gene, crossover probability, mutation probability, like this. And in this case, we used this type of value for these parameters. And this is our performance measuring criteria: accuracy, root mean square error, mean absolute error, like this. And in order to validate our model, we apply this type of data set, and our measuring criteria is the accuracy, root mean square error, measure, and these are the values. And from generation to generator, the fitness function is minimized, and this is the pictorial view how our fitness function is minimized. And at a certain generation, it reached a steady state position. And this is some error actual results and the predicted result, and this is the pictorial view. In order to validate our proposed model, we applied some classification technique, like as need by support vector mapping and neural network. And this is the accuracy our model with respect to this model. And in this table, we shows that our model gives better results than other models. And this is the pictorial view of crop recommendation system. For example, without irrigation, recommended crop, Kharif 1 season, we recommend rice, and mustard season, we sesame, and another season, we fructal millet. And this is one example of this. And another we show here, you show some another results. And this is the architectural view of Android-based application system. Actually, it is the very challenging task, because there are some features of soil are measured by the sensors, and some soil features are measured by also by chemical reactions. So it is very difficult to build Android apps for this Android apps. For this reason, we also work how to handle this type of challenge. And conclusion, We built a computation model using multi-gene genetic programming and for classify the soils, and we finally recommend the some crops based on this soil classification, and finally we implement a Android based apps for crop recommendation system. Thank you. Thanks for your attention. So I would like
Excellent,
to
excellent,
welcome
Dr. Pinto. Very nice work, I think. And in agriculture, we need precision and smart agriculture because agriculture uh, disciplined our researchers, agriculturists, they significantly contributed to achieve the food security. But in future, the sustainable supply of food and nutrition to the increasing population is really big challenge. And your model, I am not sure whether you have team members with agronomists as well as other agriculturists. Then you can easily validate the recommendation whether the match with the practically we are doing, because in Bangladesh in last 50 years agricultural research has been translated in the real field tremendously. So do you have any team members in
um,
the discipline of agriculture, especially who are in the field?
okay, actually, you know that from my presentation, actually this is very simple work, but we try to contribute something to our nation. For this reason, we just propose this type of topic, and we just collaborate with the Bangladesh Soil Research Institute to work with their so especially we need their support, because I am a, CSC scientist, but we need a soil
Excellent.
scientist
Excellent.
also.
Do anyone have any comment? Yes, Dr. Mustafiz.
Thank you, sir, for giving me a chance. And thank you, Dr. Pinto Sarkar, for your nice work. And I have not a specific question, just I have some queries about your research. And you will develop, first question, you will develop a Android application, your aim?
Yes, actually my our target is to develop a
Develop
Android
Android
application.
Okay, fine. So if you develop Android application, then which information you will use so that farmer can easily access some
Okay.
code or some little information. If you get access in your application more, the farmer will be confused. So what about your plan?
Okay, I mentioned that it is very challenging because our farmers are not educated, so they also do not know the chemical features of soil. So actually now we are thinking how to handle our farmers and how to they use these Android based apps, and actually this is very challenging works, and now we are
Excellent.
thinking what to do.
Excellent. Dr. Mustafiz is,
One question I have.
one more?
Yeah.
Okay, please.
Okay.
So maybe
Brief
I
question.
check in last slide. You have a model that is you use a sensor.
Okay,
I
yes,
don't-
yes.
It is a NPK sensor or a normal soil
It
sensor?
is actually just some sensor to collect some climate condition or like this.
I know the sensor, but
Okay.
my question, how you will integrate this sensor with Android?
Okay, our target is to apply the IoT, Internet of Things, and just we put some sensors in the soil, then collect some data, and then they input it to the Android apps. So, but I think it's very challenging because some features are collected by the sensor, and some features also collect from the chemical reactions.
Thank you, Dr. Pinto and
yeah.
Dr. Mustafiz. Dr. Mustafiz is a leading expert in biosensor and Bangladesh Academy of Science. We funded him. So please collaborate with him, as well as I can advise you to communicate with Bangladesh Agriculture Research Council. And
Okay.
if you can integrate agriculturist then you can ask
Possible.
funding from the Krishi Gaveshona Foundation.
Okay, okay,
So I
thank you.
wish you good luck and
Thank
want
you,
to
thank
see
you, thank you
the
for your
real life
suggestion.
application
Okay.
of this one.